Algebra 1, Section 3.9, the Pythagorean theorem. You probably know a squared plus b squared equals c squared. Rolls off the tongue real nice. Before we get into that exactly, I want to just talk about sort of the anatomy of a right triangle. And I've called this triangle capital A, capital B, capital C. Those are labels of vertices, obviously. And the right angle, that's what this block means, that's C. And the other two vertices are A and B. They're both acute angles at those two vertices. The two sides that are adjacent to the right angle are called legs. The one that's opposite the right angle is called the hypotenuse. Again, I'm assuming you probably know that already. I'm just kind of maybe reminding you of something you learned before. Now, why is it a squared plus b squared equals c squared? Well, the reason those letters are used is because the way we name things in math on objects like this, on figures, is the opposite side, on triangles especially, is the opposite side. So here's capital A, we would call this lowercase a. Here's capital B, the opposite leg is B. And capital C, the right angle, this is lowercase c. And then what you have, and I bet, and the reason that the Pythagorean theorem works the way it does is probably something that you did very extensively in middle school, so I'm not going to go through that activity where they draw, one thing they do is they draw the square here, and they draw a square here, and they draw the square that's attached to the hypotenuse, and you can actually visualize that, okay? You can find all that stuff on YouTube and Khan Academy and wherever else, but we're not going to go through that today. A squared plus b squared equals c squared then, using these letters, c being the hypotenuse. Okay, so the Pythagorean theorem is that. And again, I think you've probably done many activities through your schooling to really kind of visualize that. And now I just want to give you the straight algebra definition of it. Okay, so that's where that comes from. Looking at an example. Again, the hypotenuse gets its own side of the triangle, no matter what you call it. You know, let's pretend like they didn't call this C. Let's pretend like it's W. It still gets its own side of a squared plus b squared equals c squared. This is the hypotenuse. So 8 squared plus 15 squared equals w squared. Okay. Now, 8 squared plus 15 squared is 289. The undue operation for squared is square root. That's why we covered that in a recent previous lesson. So w is going to be equal to 17 then. When you take the square root of both sides is what I would have done there. Square rooting here, this gives you w, right? And then the square root of 289 is 17. That means that this is an 8 by 15 by 17 right triangle. And that would be in meters. Okay, now real quick, if I had this right triangle and this was 10 and this was 8.5, no, let's say that's the unknown. This is x and this is 14, then your setup would be x squared plus 10 squared equals 14 squared, and you'd be solving for the x. Okay, moving on. That's much like this problem here. And I'm not going to do this one. I'm just going to kind of roll through the answers. But basically what you have is a right triangle situation where you can find what they're calling B. Make sure you answer the question they're asking, though, because then that length combined with 9 would actually be the height to the top of the toy ladder there. So 13 squared plus B squared equals 28 squared. Find B, then add it to 9 to actually answer the question. They found B, and it's 24.8. So I would say the top of the ladder is 33.8 centimeters above the tabletop. Okay. Now, lastly, we have a situation where they'll give us 3 numbers and say, are these the 3? Could these potentially be a right triangle? These are the 3 lengths of a right triangle. You know, it's kind of a yes or no. Now, in our geometry book, this is known as the converse of the Pythagorean theorem. You see, the Pythagorean theorem says if you have a right triangle, then one leg squared plus the other leg squared is equal to the hypotenuse squared. Now we're going to say if one length plus another length, one length squared plus another length squared is equal to the third length squared, then it is a right triangle. One of them gives you the right triangle, and the theorem itself gives you the right triangle and says, here's what's true about it, a squared plus b squared equals c squared. The other one says, hey, if a squared plus b squared equals c squared is true, then it's a right triangle. That's in geometry known as a converse. Maybe you've figured out by now how we're going to be able to power through a lot of geometry quickly, because there's a lot of stuff that's duplicate, especially early on here in Algebra 1. So basically what they're saying, though, is test it. 5 squared plus 5 squared equals question mark 7 squared, wondering if these two are equal. Well, 5 squared is 25, so this would be 50 on the left when I add 25 to 25. And 7 squared is 49, so they are not equal. So the answer here would be no, not a right triangle. It's funny when it does that. I don't know why it does that sometimes. Not a right triangle. Abbreviating there, of course. Let's try it again with this one. Is it true that 10 squared plus 24 squared is equal to 26 squared? Okay. And again, use your calculator on this one. I don't expect you to know what 24 squared and 26 squared are. I know 24 squared is 576, but I don't know what 26 squared is. I have a thought. Yep, 676. Because this is 676. This is 576, and you're adding it to 100. I hope you do know that 10 squared is 100. So that does come out to 676. So in this case, yes, it's a right triangle. Okay. Now, one other thing, and then we'll end the video. Should I test it 3 ways? Should I have tested 5 squared plus 7 squared to see if it's equal to 5 squared? And then this 5 squared plus 7 squared to see if it's equal to 5 squared? Or maybe I can explain that better. Do I need to test 10 squared plus 26 squared to be equal to 24 squared? And then test 24 squared plus 26 squared to see if it's equal to 10 squared? The answer to that is, of course, no, because the hypotenuse is the longest side on any right triangle. The hypotenuse is always the longest side. So you only have to test it with the 2 shorter lengths equal to the longer length. 2 shorter lengths squared, of course, like this, and equal to the longer length squared. And if it works, then yes. If it doesn't, then no. Okay? And thanks for watching.